Welcome to an in-depth look at the hydraulic excavator, a marvel of fluid power engineering. At its core, a powerful diesel engine provides the initial power source for all operations.
This engine converts chemical energy into mechanical rotation, essential for the next step.
The engine drives the main hydraulic pumps, the heart of the system, creating the immense pressure required. These pumps force hydraulic oil through the system, dramatically increasing its pressure. The entire operation relies on Pascal's principle. Pressure exerted on a fluid is transmitted equally throughout. The operator's controls are the interface, translating human command into precise hydraulic flow. Joysticks manipulate sophisticated control valves, directing the pressurized fluid stream. The valves act as gates, precisely channeling the high-pressure oil to specific actuators. The linear motion is driven by hydraulic cylinders, converting fluid power into powerful push and pull. Oil is pushed into the cylinder, pressurizing the chamber to extend the piston, lifting the massive boom. To retract, the oil flow is simply reversed, pulling the heavy load back in with equal force. Each movement, lifting the boom, extending the arm, and curling the bucket, is governed by its own cylinder. These components are engineered for immense force, requiring perfect sealing to maintain pressure integrity.
Rotary motion, like swinging the cab, is handled by powerful hydraulic motors.
The pressurized oil turns the motor's shaft, allowing the entire upper structure to rotate with precision. Travel is also controlled by hydraulic motors located in the track assembly.
This provides the torque necessary to move the massive machine over rough and uneven terrain.
Hoses and lines act as the arteries of the system, transporting the pressurized fluid across the machine. These high-pressure hoses are heavily reinforced to withstand thousands of pounds per square inch of pressure. The hydraulic oil is stored in the reservoir, ready to begin the pressurization cycle. It is a closed-loop system where the oil performs work and is then returned to the tank.
After doing its work, the hot oil often passes through a cooler to manage the heat generated by pressure. Filters are crucial to maintain system health, removing contaminants that could damage the precision components.
The hydraulic system allows for immense power, combined with surgical precision in movement. The bucket cylinder generates the massive breakout force needed for difficult digging. The connection points are highly engineered to prevent leaks and maintain the high system pressure. When the East Asian male operator centers the joystick, the valve spool returns to neutral, holding the load steady. This color coding helps us visualize the two states, high-pressure work fluid and low-pressure return fluid.
The combination of force and control enables the excavator to perform heavy lifting with surprising finesse.
A central rotary joint allows oil to flow to the lower chassis while the cab swings. The engine's rotational energy is the kinetic input that the pump converts into hydraulic pressure. Pump intake draws the reservoir oil, preparing it for the critical pressurization process.
Mechanical force squeezes the oil, turning a large volume of low-pressure fluid into a smaller volume of high-pressure fluid.
The valve bank is a complex manifold that allows the operator to perform multiple movements simultaneously. Each hydraulic component operates independently, yet in harmony, through the precise valving. The longevity of the system depends on the quality of seals, which prevent internal pressure bypass. The swing motor utilizes gear reduction to convert high-speed fluid flow into high-torque rotational power. Planetary gear sets within the final drive amplify the torque for track movement. Constriction and friction in the hoses and valves are the primary sources of heat generation.
Regular maintenance, especially filter changes, is vital for the extreme cleanliness required.
The system provides modulated control, allowing the African American male operator to feather the controls for minute adjustments. Complex mechanical linkages work with the cylinders to achieve the required digging angles. The flexible hoses must withstand the constant, dynamic movement of the boom and arm components. Pressure relief valves are safety devices, diverting flow to the tank if the system pressure becomes too high. After the work is done, the oil, now lower in pressure, is routed back for cooling and repressurization. The reservoir also allows air and foam to separate from the oil before it is redrawn by the pump.
The high-torque swing system ensures fast, yet controlled, rotation of the heavy superstructure.
The conversion of low-pressure intake to high-pressure output is the defining action of the hydraulic pump. The operator feels directly connected to the power, controlling thousands of horsepower with light touch. The final drive assembly delivers the massive rotational force needed to propel the tracks. Control valves are designed to prevent sudden jolts, ensuring a smooth, predictable motion profile. Load-holding valves are essential to keep the boom and arm from drifting down under the force of gravity. Efficient cooling is vital, as excessive heat breaks down the hydraulic oil's critical properties.
In operation, one side of the piston is always under high pressure, while the other is returning oil. The engine speed is directly proportional to the pump's flow rate and the system's overall speed.
Coordinating the cylinders allows for the complex, continuous movements required for excavation.
The pins and bushings at every joint must handle the full load and digging force applied by the cylinders.
Pilot controls use a small amount of oil pressure to move the main, heavy-duty control spools. Hydraulic oil must maintain a stable viscosity across all operating temperatures to lubricate and transmit force. The precision machining within the pump minimizes internal leakage, maximizing power efficiency. Once a load is lifted, the closed hydraulic circuit effectively locks the cylinder in place.
The compactness of the engine and pump placement is essential for the excavator's counterweight and balance.
When traveling, the control valves synchronize the flow to both track motors for straight movement.
The engine's cooling system must work hard to manage the heat generated by powering the hydraulic pumps. The oil returns to the tank gently through a diffuser to prevent aeration and turbulent mixing. Oil pressure can reach extreme levels, allowing for the incredible forces exerted at the working end. The swing bearing is a critical structural element, supporting the entire load during rotation.
The speed of the operation is directly controlled by the volume of oil that the pump can supply.
Foot pedals provide additional control over the travel and steering of the machine.
The fluid force is converted into rotational motion by pushing against the internal rotating elements of the motor. The fine control allows the excavator to transition from heavy digging to delicate material placement. Every seal and gasket is a potential failure point, and their integrity is non-negotiable for system pressure.
The diesel engine requires its own precise systems to generate the continuous power for the pumps.
The counterweight balances the enormous forces exerted when the boom and bucket are extended with a full load.
Once the pressure is released, the oil quickly transitions to its low-pressure state on the return path. Regular lubrication of the pin joints minimizes friction and wear on the high-load articulation points. In standby, all control valves are centered, ensuring no unnecessary flow and maintaining system readiness. The hydraulic excavator is a perfect synthesis of mechanical and fluid power, built for precision and strength. This closed-loop system ensures that every drop of power is harnessed to complete the most demanding tasks.